in order to write equations and inequalities for these three stories, you have a basic structure you're dealing with every single time. And the basic structure starts like this. Here's the formula for the structure. It's not going to make a lot of sense when I first write it, but it will as you use it. So for right here, so with this equation, what this equation is saying is P stands for your principal, your initial amount. Then right here is your rate. It's either going to be 1 plus or minus your rate as a decimal. Here is your time frame. Depends on what time you're dealing with. And that's going to be equal to your final amount. That is one formula you're going to run into. The other formula looks very, very similar. It's going to be this. There's two different possible formulas you're going to run into. This one starts with P again. P stands for your principal, which is your initial amount. E is that 2.71 number. It's that natural log base, E. And then your rate is now an exponent, and your time are multiplied together as a power. And your final amount's here. So they're very similar, except whenever you have this E is when you have the word continuously compounding, or something continuously growing or shrinking. So the word continuous is going to use this E, otherwise use this formula. They both start with P, they both end with your final amount, they both have R's and T's, it just changes how they are set up and how they, which structure you're going to use. Now, we are going to this problem right here, so let's read it carefully. How much of an initial investment would you need for it to be worth at least $3,000 if it is compounded yearly at 5% over 4 years? Creating an inequality, do not solve it. That would be used to find the initial investment. So we're trying to find the initial investment. So are we going to use the blue or the red formula? Well, I didn't hear the word continuously compounding. So we are going to use the formula right here. So we got to look through this problem and one by one find out what each piece is. So the 3,000, we got to decide which is the 3,000. The 3,000 go here, 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 here. Which is 3,000? So I'll make a list of these. What is the 3,000? Well, let's think. It is at least worth 3,000. Is that 3,000 going to be an initial or final amount? Hopefully you can see it's a final amount. So my A is $3,000. That's what I'm going to end with. Okay, what is this? That looks like a percent. Isn't that a rate? I mean, yeah, percents tend to be the rate. So the R is going to be 5%. And what do you think? Growth or decay? Well, it doesn't say. Let's assume the money's growing. So we're going to grow up by 5%. We're going to be growing up by 5%. Next, 4 years. Hopefully you can tell that's time, so that's probably the T. So T equals 5 years. And let's see, any other information? No other numbers. What do we want to find is the initial investment. So aren't we trying to find P? Isn't P what we're looking for? So that's going to be the blank spot. So here we go. To write the equation, we're going to do something like this. 4 years. So, oh, I did mess up. That should be a 4 years, not 5 years. 4 years. All right, so we are going to make this up. P, 1 plus or minus R to the T equals A. Here is P, 1 plus or minus R to the T, A. And we have to decide what goes here. It's actually not going to be an equal sign. You'll see. So can we simply plug these numbers where they belong? According to this formula? So let's look. Where does 3,000 go? Isn't that your final amount right here? So I want 3,000 go right here. Okay, my rate, it's upward of 5%. So my rate goes right here. And if we're going up, aren't we going to add the rate? So my rate is going to be 1 plus 5%. Now be careful. 5% is 0.05. 5% is like 5 cents. So it's 1 plus 0.05, which will end up being 1.05. Okay, and the last one's a 4 years. Is 4 going here or here? Well, isn't time go up here? So my 4 years go there. So we're trying to find this. So could I put P or could I put X? Does it matter? No, it depends on what letter you want. You can put P or X. It's your call. I'm just going to put X, because that is what we're trying to find here. So we're trying to find X. We're trying to find that value. The initial amount of money I need to get this much. Now my last question is this an equal sign, a greater than, a less than? What is it? Well, it says it's an inequality. And it said the word up here, it said at least $3,000. So if I want at least $3,000, I am looking for $3,000 being the lowest amount possible. So this has to be the lowest. So aren't I looking for things above that? If I have at least $3,000, aren't I looking for things above $3,000? So how do you write above $3,000? Isn't that going to be bigger than or equal to $3,000? If I want at least $3,000, aren't I looking for when my values will be bigger than or equal to $3,000? For this one, there are 2,000 fish in a pond. How do you know that? Let's just assume you know. Say you put them in yourself. Fish in a pond, and their population is decreasing at a continuous rate of 2%. Create an inequality, but do not solve it. That would be used to find out how long it would take for there would be at most 10 fish left. So your fish are dying somehow, or you're fishing for them, depending. So, which formula am I going to use? Well, that's the key. See the word continuous right here? Yes. Because I see the word continuous, I know I'm using the red formula here. Whenever you hear the word continuous, it's that E formula. So we are going to use this formula. So let's set up this formula and find all the pieces. Actually, before we find the pieces, let's find each piece. We got to find what we're looking for. So we got to look at each number. What does each number represent? So the 2,000, is that your initial or your final amount? Is that your P or A?
It's your initial.
That's your initial amount. So your P is 2,000 fish. Okay, next, 20%. That looks like your rate, but it's decreasing. Be careful here. That's a decreasing rate. So my rate is going to be decreasing, so that's a negative 20%. So it's going to be going down, which is negative. 20% is 0.20. Okay? Oh, sorry. That would be 20%. Going down by 20%, which is a negative 0.20. So this right here is your rate, just so you know. That is your rate in a decimal, but it's going down by 20%. And our last piece is, I want 10 left. So 10, isn't that my final amount? So my A is 10 fish. So could I put all those into this formula and have my equation? Well, in this problem, it's actually inequality. So let's set it up. We have an initial, we have E, and we have two values that are going to be multiplied here. And we have our final. So we have the initial, the rate, the time, and the final amount. We're using this formula right here. So my initial is the 2,000. My rate is the decimal, not the 20%. It's a decimal, so it's a negative 0.2. Negative 0.2. We do not need to put the 0, but you could. My time is, well, we don't know time, do we? Isn't that what we're trying to find? Are we trying to find the time? How long? So that will be my X. Do we know our final amount? Yes. Our final amount here is 10 fish, because we're shrinking. So that's my final amount. And I need an inequality. So my inequality, I have the word here, at most 10. When I say at most 10, that means the highest it could be is 10. So the biggest this could be is 10. I want below that. So don't I want values below 10? Don't I want this to be below 10 if it's at most 10? So below would be less than or equal to 10. I can have 10, but I want that or below, because it'd be at most 10, so I just 10 or below. So that would be my inequality right there. For this next one, assume you have 4 bunnies, and a month later you had 12 bunnies, and the next month you have 36 bunnies. Create an equation but do not solve it. That would be used to find out how many months it would take to have 1 million bunnies. Now, bunnies can multiply quickly. This one's a little bit harder. My question is, which one are we doing? Well, it doesn't say about continuously compounding. Even though bunnies do continuously compound, I'm going to go with this one right here because it doesn't say anything about continuously compounding. So I'm going to use this one. So do I know how many bunnies I started with? 4. Well, yes, I do. I know I started with 4 bunnies. Or rabbits. Depends on what you want to call them. All right. Do I know my rate? No, there's no rate in this whole problem. Do I know how much time? No. Do I know my final amount I'm looking for? I do know it's 1 million. So my A value is going to be 1 million bunnies. Okay, but I don't know my rate. How do you find your rate? Well, that's a little tricky here. Let's make a table to help us find our rate. Here's what I mean by a table. If I have a table, this is time, and this is bunnies. So at time 0, didn't we say there's 4? At 1 month, didn't we say there are 12? At 2 months, didn't we say there's 36? From this table, can you find the rate? Can you see how it's changing? Hopefully you can tell they're tripling. Aren't they tripling?
Yes.
So we're tripling. Now, how would you know that if you can't see it? What you do is you take 12 and divide by 4. To find the rate, what you're going to do is you're going to take 12 and divide by 4, which is 3. So you are tripling each time. Now the rate is a little bit more confusing here. Really, if you're tripling, that's a 200% growth. That's going to be a little trickier. So I'll put that in a second. It'll make a little bit more sense as we write the equation. But you're tripling, which would be a 200% growth. I'll mention that in a second. But we need our initial amount. We need our rate. We need our time. And we need our final amount. We know our initial was 4. That was given. We know our final is 1 million. Which one are we trying to find? Well, are we trying to find x or rate? Aren't we trying to find x here? What was our rate? What was our multiplier? Isn't it 3? Aren't we tripling? So won't that 3 go right here? That 3 is what goes right here. Now, hopefully you understand that's 1 plus 200%. 1 plus 2 gives you 3. So you're really going at a rate. Your technical rate of growth is a 200%. Because that's 1 plus 2 to give you 3. So you're technically growing at 200%, but that's not necessary for the problem. Let's just use the 3. Now, are we using equals or greater than or less than? Well, what would it take to have exactly 1 million? Means this is going to be an equal sign. So we start with 4. We're tripling x times to make 1 million bunnies, and we're wondering how long that would take. So with all these problems, you're using these two structures. You're filling in the pieces where they belong. And in this problem, you actually had to find your rate using the table of values to do that. Be careful. Some are inequalities. Some are equations. Some are continuously compounding. Some are just the regular, non-continuously compounding. Good luck.